Hello everyone, welcome to the webinar from Byte Academy and Nestria. Before we get started, please join us in our free Discord community to enhance and extend the experience of this workshop. I will be sharing the files on Nestria Discord server at the end of this event. Discord and Nestria link has been shared in the description box. I will give you a brief about Nestria. Nestria is Byte Academy's sister company. You can think of it as a portal for everyone from networking to technical and career advice. Welcome everyone once again. This is Shubhankar from Byte Academy. Let's get started with the topic today. So our today's topic is Introductory Mathematics Behind Simple Linear Regression Algorithm. So we will look at the agenda for a few minutes and we will try to explore what we are going to learn in today's webinar. First, we will get a brief introduction about machine learning. Here we are not directly jumping on the linear regression concept because we need to understand certain aspects of machine learning before we can completely explore the mathematical intuition behind the linear regression model. So I will give you a brief introduction about those basics which we're supposed to know or we're supposed to clear about in machine learning. So the first thing, what is machine learning? Okay, I will give you a brief intro. Then what is data in machine learning? Data is a very crucial part of the machine learning. Every machine learning story starts from the data. So we need to understand what really means by data in the machine learning. And then we will look at the end goal. So what is the end goal? What we are trying to do in the machine learning? Then what is a model in machine learning? So model building is the major part of any machine learning project. So we will see what does it mean by a model in machine learning. Now, next is what does it mean by training a model? Now you might have heard about training the machine learning models, but what exactly does it mean by training a model? That we need to understand from here. And that is one of the more goal of this webinar, to give you an understanding of what does it mean by this term called training a model. Okay. And this linear regression mathematical intuition will give us more idea about this training process and what does it intuitively mean. Next, we will explore what is a cost function. Cost function plays a very important role. So what exactly is the role for a cost function? How it is so much crucial? So we will also look at that aspect. Next, how cost function works. So obviously, when we know what is a cost function, we also need to look at how this works. So we will overall get an idea about the, starting from the data, building a model, training a model, and how to evaluate the model as well. But here, what we are not going to do, that also I need to clear from this moment. We are not going to do any coding or practical aspect on writing a Python code or maybe a R language code. We are not going to write any code. We will try to understand the concepts using some graphs, some images. That's what the goal of this webinar is. So I will start with what is machine learning. So as per the definition goes, machine learning is an interdisciplinary branch of science and technology that utilizes the mathematical and statistical tools on the available data to create predictive models. Now, here on this definition, there are certain terms that might not make sense to a person who is listening to this term called machine learning for the first time. But I will try to clear those points out in the subsequent slides. So, second, what is data in machine learning? So, let's assume we have collected some real world data from some source. Okay, so the data that I have put over here, it is not obviously a real world data, but we will assume it is a real world data and it represent some real world scenario as well. So here we are talking about the year of experience and the corresponding salary one might expect. Now here, this is, as I said, it is not a real world data or specific to any field. It is just a data for the sake of experiment. So here we can see there are two columns, year of experience and the salary in terms of 10K. So here, if the year of experience is 1, so here the salary is 20K. 2 means it will be considered as 20K. Similarly, 2 years of experience, the salary will be 30K and so on. So this is the data we have. Now we will see what is the end goal of machine learning. Now, for any machine learning beginners who is starting with machine learning, this is a very important idea they need to be aware of. What is the end goal? What we are basically trying to do? Why we are using the machine learning? So our end goal in machine learning is to create some equation, function actually. Okay, so here I have put the word function in the bracket because we are more familiar with the term called equation. That is the only reason, but mathematically there was some differences, or there is some differences between the equation and a function. So we need not to worry much about that. Now here, the equation that we are going to create, see, we are going to create or design our own equation, which will be able to predict the salary if I put the year of experience as input. So here on the left hand side, you can see the data that we had. So 1 year of experience supposed to get, 20K of salary, right? This is the practical data we can consider. Now, if from this data, if I am showing someone this particular data and asking what will be the salary for a person who is having 6 years of experience. Now, over here in the given data, or already the data that we are having, there we can see we have record for 7 years of experience, we have records of 10 years of experience, but in between we don't have any record. So here, when the question will come, what will be the salary for a 6 years of experience person, there we need to predict the salary. Similarly, for 8.5, let's say that is another question. What will be the salary for a person who is having 8.5 years of experience? That's what we will try to predict. And that is the goal of machine learning, that we will make such kind of expression, we will create such kind of equation where we can inject this year of experience and we can get out the salary, or I would say it will predict the salary. It is never exact, it is predicting the salary based on the input data we already have. Now, let's say we have done some machine learning, algorithms we have run, we have trained, and we got self, we have created some machine learning model that says y equals to 0.73x plus 1.5. So this can be a legitimate machine learning model. And indeed, it is a machine learning model. Machine learning model simply is a mathematical model only. Okay. Now here, real time, if you inject the 6 in the place of x, as 6 is the input, okay, we are trying to look at the salary, or we are trying to predict the salary. So here, if we put 6 in the place of x and calculate, we will get the value of y as 5.8 approximately. We will get the value as 5.8 approximately. Similarly, if we inject 8.5, approximately we got the value of 7.7. Okay. Now, from where I created this particular equation, x and y, it's fine, but from where I got this 0.73, 1.5, that is what the goal of machine learning. And I will try to give an idea about what's happening over here in this webinar. So what is a model in machine learning? In machine learning, we use statistics and mathematics to create custom equations. As I said, functions in reality. In these equations, I will keep on using the term equations. I am not going to use the term function, as you know, it's not that much familiar. Okay. In these equations, there will be input parameters like years of experience. There will be output parameters like the salary, which we will try to predict. Now, as an example, y equals to 0.73x plus 1.5. Now here, x is known parameter, years of experience. Y is unknown parameter, which is salary, now which we are trying to predict. Now in machine learning, we already have some standard equations created by researchers. Here, one standard equation I can show you, that is y equals to mx plus c. Now here, m and c are constants. Now this equation might be familiar to someone of you because this is the equation for a straight line. Now here, the x and y, I hope you can recognize this x and this y. But in the place of m, I have put 0.73, and in the place of c, I have put 1.5. But the question is, how do we have decided the values of m and c in our case? It's okay that we have some standard model y equals to mx plus c, but how we have decided the m and c values? Let's see that. There comes the training of a model. Now, we have some standard models in machine learning, as we have seen in the last slide. Now, let's say y equals to mx plus c, and this is indeed the model for simple linear regression. Now, for our problem, we have chosen m equals to 0.73 and c equals to 1.7. Now, this process of finding the values of m and c specifically for our problem statement or collected data is called training the model on the data in the real world of machine learning. Now here, I need to emphasize on this particular paragraph because this unfolds all the mystery. Here, when we say we are trying to model, or we are trying to, train a machine learning model, we are basically trying to find out the value of these constants in some way. Let's not worry about that how, but in some way, we are trying to find out the value of this constant. And that is what called as machine learning model training. Okay. Now we will, get into the linear regression. Okay. So On the left hand side, the same data we are having. Imagine this year of experience is represented by X and salary is represented by Y. Now, if we have a simple 2D graph and I can plot these points, X will be in the along the X-axis is the horizontal line, and Y will be the vertical line. Now over here, if we are trying to plot these points, it will be somewhat like this, these points. Okay. Yeah. So here 1, 2. So it will be around over here. Then 2.5, 3. Now, simple linear regression training. Now here, if we are trying to see how we are going to train a linear regression model or simple linear regression model, by the way, let me tell you, here there are different types of linear regression. There is simple linear regression, there is multilinear regression. Okay, we will deal with simple linear regression in today's webinar. Because it is easy to visualize and get an intuition about it just by looking at graphs. If we go for higher dimensions in the multilinear regression, it will be difficult for us to visualize. Mathematically, based on the given data, training a linear regression model means finding out M and C value for the equation y equals to mx plus c. We are well aware of this fact, right? Just keep this in the back of your mind always. What does it mean by training? Now, question is on what basis? What are the arguments or points that we want to consider while deciding the values of M and C? I have said that what does it mean by training? Finding the values of M and C. But how we will decide? What are the points? What are the arguments we are going to make? As we are dealing with mathematics, mathematical models or equations or functions, we are in the world of mathematics. And this is a good idea. Why? Because in this world, we have systematic ways or tools to perform such actions like finding some specific values of the unknowns like M and C. And we might remember from our early school days, we used to find the value of unknowns. That's what we are trying to do over here. Now, as a human, it is always easy for us to understand the graphical representation of what's going on and then extend it to the formulas and calculations. That's helpful for me, and I hope this is also helpful for others as well. So simple linear regression training. Now the points on the graph represents the known data. Okay, the data that we already know. Now we have used values of X, years of experience, Y, salary to plot the points. Now we already have some model available with us, SLR model or short form for simple linear regression. We will use our data to train this model. Means we will find out the M and C value for this model. Now I am going to disclose what exactly we are going to do or what exactly graphically means by training a model. So we know as a statement, we are trying to find out M and C values, but graphically, what does it mean? It graphically means finding out a straight line or position a straight line that pass among the points. See, I cannot say pass through the points because a straight line needs 2 points, right? At least 2 points, right? But here, all the points are not in a straight line. Even if I draw, maximum I can fit 2 or 3 points, but that's not the goal over here. We will explore that gradually. So here we need to position a straight line in such a way that the sum of total distance from the straight line to the points will be minimum. Now I will show you in the next slide what I try to mean by that. So in this slide, we can see when we try to put the, this straight line, this is not passing through all the points. It is missing almost all the points, right? Maybe this point, this top point is, aligned with or on the top of this straight line. But here we can calculate how much away it is. So for each point, the red line that you can see over here, this is the error, we can say. This much away the point is from our straight line. Similarly goes for the other points as well. Okay, so we can calculate, literally add up and calculate these distances and sum them up. Okay, and that will be considered as a total error. Now we need to place the straight line in such a way that the added values of these distances should be least, and this is the magic point over here. The whole argument, how to find out the, or on which perspective we need to decide the value of M and C. We need to decide the value of M and C. See, first of all, whenever we are deciding the value of M and C, it will be creating a straight line. So what is the evaluation point? How we will decide what is the best value for M and C? It will be the straight line in such a way that the total error, means the distance from all the points, will be minimum. The line should be in such a way. Let's see an example. Now, simple linear trading. Now here I have, just randomly guessed some values, not purely randomly, otherwise the graph will look crazy. So here I have kept this 0.8 constant, means M value constant, and I have played with the C value. Now here C value I have put 1.5, I have put then 1, and then I have put 2. Now if we look at it, the different straight line it has drawn along with the points. Now we can see that here, if we draw that red line, that perpendicular line, the error will going to be different for a different line. So this is the proof that if we decide different values of M and C, the error will also going to change. And our aim will be to choose the M and C in such a way that the error will be least. Now, very important point. Now, it is practically impossible to guess the values of to guess the values of M and C and then compare every time which error is less. We can, go for 1,000 guesses for M and C value, and then we will compare in which case the error is coming less. And it will take for us, for a whole lifetime. But the point is not that. The point is, even if we try randomly, there will be an uncertainty of what? About the fact that whether we have got the best fitting line or not, whether we have got least error or not. What is the guarantee that the least error from my choices is the least error in reality? Maybe if I am going for 500 more different iterations, I am going to get more or less value. There is no guarantee, there is uncertainty, and mathematics doesn't, accept or encourage uncertainty, right? And there comes the mathematics to rescue us as we are playing by its rules, right? So we are going to use calculus and cost function. So cost function is a, we can say that is a product of calculus or a tool of calculus, okay, to firmly give us a solution where there will be no error. I mean, like we will be certain about the fact that yes, the minimum value that we have got, it is indeed the minimum value. There is no less value possible than that. Okay, and I will prove that thing. Okay, so here we go with the cost function. So this is a little bit scary for me at least, but it is simple. Over here, this n, this is a left hand side, this is the final value we are trying to predict, okay, on the left hand side. Now here, as I was saying, we are trying to design a function, right? So this cost function, that's why. Okay, now on the left hand side is the total error we are talking about. Okay, so I am leaving the left hand side for now. Let's look at the right hand side. So n is the number of records. It's very simple, right? I have here 5 records, 1 2 3 4 5. Yeah, I've got 5 records, so n value is 5. It's simple. Mx plus c, I think this is absolutely familiar for us. Mx plus c, just y equals to mx plus c, right? So that right hand side I have written over here. Okay, and then there is a minus y. Well, here if I want to tell this m and c value, we are trying to find out. X value is already known, year of experience. Y value is already known, the salary. So here I hope the formula is less scary now. N, number of records, M and C, we are trying to find out. X, a year of experience. Y, salary. Now what does it mean by this I? It's just simply saying that when you are considering 1 year of experience, please consider the corresponding salary as well. That's why I, subscript I with X as well, subscript I with Y as well. It is just saying that choose the corresponding value mathematically. Now, why cost function is so important? Why we need to take the pain of doing this? Okay. Now, here, the whole right hand side, I have already explained what are the meaning of this particular terms, right? Now, this M and C value that we are trying to find out, okay, or the position of the straight line, or which we get in the minimum sum of total distance from the straight line to the points that I told that time, right? When we are drawing the straight line, we are getting some errors, right? So that error we need to minimize. That error is the left hand side over here. Okay, if I keep on putting all the points over here, like from the first iteration, I will put 1 in the place of x, in the place of y2, like that. If I keep on put all the points, I am going to get some error. Okay, because I am going to choose some fixed value for M and C. Okay, so graphically, what does it mean? Here, if we see, first of all, I am assuming M as 0, because if I am not assuming M as 0, so there we were trying to guess 2 things, right? M and C. For now, to make things simple, I am assuming M as 0, because so that we can, visualize this in a 2D. Okay, now we will assume some random values of C. Let's say, okay, in this equation, after expanding this equation, okay, let's not go into the detail for that, how to expand this equation. Okay, so let's say I have expanded the equation and there is only unknown is M and C, only unknown, as I'm saying repeatedly. Okay, now I have chosen M as 0. I have made the M as 0. Now, if I assume random values of C, what will going to happen? I am going to get a curve like this. If I plot the error that I am getting in the y-axis against the values of C, I am assuming. Okay, so I am assuming a value of C, I am getting some error. I am assuming another value of C, I am getting another error. So this corresponding value, if I plot in X and Y, X being the C value and Y being the error value, then I am going to get a curve like this. Okay, now as it is, a visual, I can clearly, so what was our goal? We need to find out the minimum value. Forget about M for now. We need to find out. So if M goes away from the picture, only C value we are talking about. So we need to find out a C value where the error is least. Where is the error locating in the y-axis? Now visually anyone can say the error will be around that red dot. The error will be around that red dot on the y-axis right over here. And what will be the corresponding C value? just right over here perpendicular to the y-axis. That means the C value over here. So that is where mathematical magic comes in. We easily, just by looking at it, we can tell where it will going to be the minimum error for the C value. That's what everything, that's what our goal was. I know our goal was to find out both M and C. Now I will extend that concept as well. Here we go with not making the M 0, because in reality, we cannot make the M as 0. We have to keep the M, right? So if we keep the M, then both M and C, if we keep, then we are going to get a 3D curve. That was the reason I was avoiding that in the first place. So in the first picture, we have visually find it out, right? Visually. Mathematically, actually, we need to use a method called gradient descent. Obviously, visually, just by looking at it, we can find out, but mathematically, there is a method called gradient descent. It's not that scary, but yeah, it is a calculus method. Okay, now if I extend that or generalize this, both if in terms of M and C, we can see that also just by visualizing it, I can tell that at the bottom part, it will going to have the minimum error rate, and the corresponding, what about the corresponding M and C value? The corresponding M and C value, M is this theta1 and C will be this theta, if I am not wrong. Okay, so I need to look for the data as well, what I considered as what, but that is the point. Maybe C could be the theta and M could be the theta1, but the point is here in the y-axis, MAC cost can we see over here. So there, when the y value is least on the graph, visually we can easily say that that is the point where we are going to get the minimum M and C value as well, and that is the M and C value we are looking for, and we will say that our graph is, or our model is trained. So this is how the simple linear regression model works, and I tried to explain the concept of training the model and what does it exactly means, and what is the intuition behind the cost function and why it is used and why it is important as well. Okay, so thank you very much. But before we end the event, I will give you a quick tour of the Nestria Discord server. Okay, and don't worry if the link is a little bit different on the slide and in the description, it will land you to the same page on the Discord server. Okay, so just give me a second. All right. So here we go. So this is how the Nestria server looks. This is how the Nestria server looks. You can start by joining a topic. So whenever you will click on the link, it will directly, keep you over here to start. All right. So you can always join a topic of your choice. And under this Discord server, we have got different channels for Python, channel for data science, okay, channel for JavaScript, okay, where there will be lots of resources sharing, okay. And indeed, I will be sharing my file as well, not under JavaScript, obviously under the data science resources. All right, as it was about data science. Similarly, you will find out career related channels as well. Okay, so you can just join us to get started, and also subscribe the YouTube channel for more upcoming videos. Thank you very much. Have a great day ahead.